I just like, dude, now you're like starting to hate the Algebra 1 teacher you might have had. Unless it was me, then you really hate me. So, I'm kidding. Any questions? Feel good about even the domain? Any questions on domain? Some of the domains can get goofy. Was there one that was kind of a goofier looking domain that I could help you with? We're solid. Equation align. Good with that? Okay. So let me bring up a domain question. I know that there was one I was helping a couple of you with, and they're like, Stirp said you need help. I just deal with Stirp's madness. All right. So y equals, this is number 10. Okay, is that it? Okay. I feel like I have something wrong on that. What did I miss? Oh, I know what we did. Okay, so that's the graph you would have gotten for number 10. Do you agree? Okay, so this is where we have to be careful, my friends. Does anyone know what's going on with this equation? Why we only have one horizontal, one vertical asymptote? Anyone know what the problem might have been? There's two answers that if I plugged into the denominator, that would give me two answers that wouldn't work. So it's not an I. Oops, here. So the number 10. So they had this as the equation. And then x squared minus 2x minus 15. Okay. So in this kind of case, when you're looking at the graph that was given, the graph is right. Okay? But there's something that's taking place on this problem. So you have to kind of go through and say, okay, can I factor this? Now, if you're not real good at factoring, one key to take a look at, I have this binomial here and this binomial here. What did those two binomials do in place of an asymptote? That's a hole. Okay, so we have a hole at -3. Okay, now I'm not sure exactly what the exact y coordinate of that hole, but at -3 there's a hole. So that's going to mess with our graph. So if we look at our graph, oops. So it's saying that -3 is a hole. So if I go right here, what does it say for the y value? Okay, but that hole is different than an asymptote. Now, I don't think Desmos will do it as nicely, and I'm just see if I have to play with this a little bit. Okay, so the graphing calculator does a little nicer job here because I'm zooming into ridiculous close. And I'm just looking to see if there was a hole in the graph. Something's starting to get a little shaky. There we go. That's what we're looking for. Okay. I'm as close as I possibly can, but as you start progressing in, notice what's happening off to the left and to the right. It's like that darker shaded. So that means that something that's happening in between the two is creating a hole. Now on the Texas graphing calculator, I'm just going to show you what that does as well. Give me a sec to pull it up. And it takes a moment to start up because I haven't done it in a while. All right, y equals. We're going to do x plus 3. Oops. X plus 3 divided by x squared minus 2x minus 15. Oops. Ah, boogers. Ah, you're killing me. X plus 3 divided by x squared minus 2x. Oh, 2. Ah. Sorry. I just had to deal with Algebra 1, so my frustration. I can't yell at my Algebra 1 kids because they start crying, and then their parents say, "Why'd you make my kid cry?" No, don't worry, I'm not going to yell at you. Minus 2x minus 15. All right, we got it. Thank goodness. So if I do a zoom standard on my graph, so this is basically what our Desmos graph looked like. So what I want to do is I'm going to start zooming in. I'm going to move this over this way to, what did I say, -3. So I'm going to get as close to -3 as possible and enter. And I'm going to keep getting this as close to -3 as I can. Basically what I'm doing is this has happened in the past, and I just don't know if it's still going to happen. What I'm basically doing, there we go. So I have zoomed in a number of times. I'm ridiculously close to that point. So that line should be a straight line all the way through. And that little dip where it looks like kind of like a heartbeat EKG or part of one, that means that there would have been a hole there. Okay, and the closer and closer I take that, the more it's going to get all goofy. So that jiggly region there, that's what a hole looks like according to the graphing calculator. So some weird destructive interference. Okay, so I just wanted to show you that. So the key on some of those is, item number 1, how would we know that we should have 2 undefined terms on this just by looking at it without going much further than just looking at the problem? What sticks out to say there's two answers in the denominator? It's raised to the second power. Okay. So the nice thing when you're dealing with a whole, look to see, do I have a binomial on top that creates a whole? So because we create a whole at -3, so -3 is going to be a point that I can get up to, but I'm going to go rounded brackets. I'll probably have this. I think it's -∞ to -3, and then 3 comma, if I go back to Desmos and just take it back to normal, go back to home. So then I also have at 5 another asymptote. So at 5 I have an asymptote, and then 5 to infinity. So this created a vertical asymptote. This created a hole. Okay, and a hole is literally the difference between a hole and an asymptote. A hole, you would draw your line up to that point, pick up your pencil, move it to the other side of it, and keep drawing. So you're not going to see upward downward motion, or both up or both down for an asymptote. A vertical asymptote, you're going to see it like shoot straight up or shoot straight down, and they could go both straight up or they could go both straight down. So just be cautious. I know that I'm giving you a quiz on Schoology, which you'll have the opportunity to do at home, but one of the problems will indeed have a hole in it. There's multiple choice, like select all that are true about this equation, and don't miss that one little point because there's a hole in it. Even if when you're looking at the graph you can't distinguish a hole is taking place, but if you were to go back in, even if you went on the TI and you went to the if you went to the table, you would see at -3, it'd say -3, and then the y value would say error. Okay, and that's where a hole is taking place. So a hole is hard to sometimes determine unless you realize what constitutes making a hole. And it's if you have a binomial on top that will cancel with a binomial on bottom, you set that binomial equal to 0, and that's the x component of where the hole would take place. Okay? Is that okay? Everyone's fine? And I don't know, is there any other way on Desmos I can make my graph look different? Just wondering. Done. Just don't know if I can make that connected versus not connected. Ah. No. Got it. None of those are going to help me with the hole. So just so you know, where my cursor is, that is where a hole exists on the graph. And because of using the graphing calculator, if you recognize it, if you zoom in a number of times, you're going to see that something's going to start taking place there at that -3. So just be cautious when that happens. Okay? So what today entails is, let's say we have some sort of graph that looks like this. So right now, they would call this something called a relative max. And this value here is a relative min. So how it's going to refer to you on it, on Desmos, if you click here and get to the max, it's going to give you an XY value. Give me the whole XY value. If it gets to here, it's going to give you the relative min, which is also an XY value, a point. So it'll hover on it. So let me show one on Desmos that is not this one. But let's say I had y equals x raised to the third plus 7x to the second. That looks nice. All right, so if I zoom back on this, make it a little thicker so we can see it. If I zoom out on it, if I come to this point right here and click up here, that's where that point right there is called a relative max, or they might just say a max or a min. Okay, it's going to be the same thing. And this point right here is where I have a relative min. The absolute max and the absolute min are infinities, but the turning points on the graph, you just kind of know that. That'll take place. Other things it's going to ask you for, it's going to ask, hey, where's an x-intercept? This right here, the 0, 0 is also an x-intercept because it's a bounce that's taking place there. Okay, and then so let's change this up a little bit more. Let's go plus 5x. Oops. Plus 5x minus 3. Okay, so if we had something like this, and it also asks where it's crossing the x-axis, if you click on these dots, as long as the y component is 0, those are where it's crossing the x-axis. You can also, so it's label all key points, so we want x and y-axis crossing. It finds the y-axis when you come down here, as long as their x component is 0. You can find where it's crossing that, and then just start going through, and you can label all your points, knowing where you have maxes or mins, x and y-axis. Asymptotes sometimes get harder to see, but try and zoom in to see where it might be a vertical or horizontal asymptote. The rules of algebra, basically for a vertical asymptote, is where the denominator equals 0. So you'd solve that. The horizontal asymptote, there was a few rules to it. So if degree on top is greater than degree on bottom, you have something called a slant or end behavior asymptote. So that means as you're going to the infinities, what is it going along? If the degree on top is equal to the degree on bottom, it's the lead coefficient over the lead coefficient. And then if the degree on top is less than the degree on bottom, then your asymptote is at just x equals 0 for your horizontal. Okay, so let me show you what the lead coefficient item is, and it's sometimes easier to spot. So if my degree on top, is less than the degree on bottom, so if I x to the 5th, oops, x raised to the 5th. So that means that 0 is my horizontal asymptote. Okay? If my degree on top and bottom are equal, this horizontal line is at 3 over 2. 3 over 2 is at 1.5. Okay, so 1.5. So that's another way to do it. And then if your degree on top is less than the degree on bottom, then you have something called the end behavior. So as I continue to the right, it's going to follow something. As you go to the left, it's going to follow something. We'll talk about horizontal asymptotes later. And I think the only other thing you need to know is you have natural log. That's going to be given to you on one of your problems. In order to find natural log, I believe you can just type ln. So if I want natural log of x, that's what that would look like. So as soon as the ln goes up, or if you had log, you could go y equals, if it was log of x, that's what log of x, so natural log. So you actually just type in the ln and then put the variable. As soon as it goes to a straight up and down thing, it means it's a mathematical function that'll take place. All right, so Stirrup has spoken enough for today. Why am I talking myself in the third person? Because I'm a little bit goofy. Graphing review number 3. And I'd say this will be due at the end of the period tomorrow. Okay, so I'd say get a start on it, and then I'll work out any or all of them that you need. But that's what I got. Sound like a plan? Everyone happy? How was all of the rest of your